we're skipping up to chapter 11. So we skipped, what would we end up on, 8? So we skipped 9 and 10. All right, so let's go to 11. Two reasons why we're doing 11 is because one reason is it's actually a little easier than the stuff that we've normally been doing, I think. For the most part, not everything, but for the most part it is. And it's also short, all right? So we only have a week, so I'm going to try to get this finished in a week. Why did I put 11-2? I don't know. It would be better if we started at 11-1, wouldn't it? Yes, and we are. We are starting at 11-1. Okay, so here we go. What we're going to do is we are doing area. Now, you should know several things about area up to this point. Okay, when you're a little kid, you learn about area and that kind of stuff. And we're going to learn, we're going to review probably some of the same stuff that you remember when you're a kid learning this stuff. But we're also going to throw in some new things as well. All right, let's start with this. I think you're all familiar with something that looks like this. This looks like a rectangle, doesn't it? And you remember how you learn the area of a rectangle? Well, just how did we find the area of a rectangle? Length times width. Okay, that's what we usually say, isn't it? I'm going to change that a little bit in here, but basically that's what it is. There's nothing wrong with that. It's perfectly fine. It's length times width. Does it really matter which one is the length and which one is the width?
Not really.
No, it doesn't make any difference, okay? Now, you can't have this one the length and this one the width. You with me on this?
Yeah.
Okay, it's got to be the two different sides. One side is the length, and the different side is the width. Okay? I just want to show you. I probably should have had this drawn a little bit better before, but that's okay. Watch. If I was able to break these up into perfect squares, just bear with me. I don't think they're going to be nice perfect squares, but you're going to have to use your imagination just a little bit. All right, because I'm not going to take all the time in the world to make sure that they're exactly perfect. But this is basically going to give you an idea of why the area is the length times the width. Now I know these don't look like perfect squares, but let's just pretend they are. Is that all right with you? Okay, some of them look pretty close, but let's pretend they're all perfect squares. It's just as much this length and width are exactly the same. Again, pretend. Everybody with me on that? So if I wanted to find out how many of these squares that I have in this rectangle, you could just count them all up. 1, 2, 3, 4, and keep on going like this. What would be an easier way? Do you remember that? Like if you had like, well listen, if you had like a big old room of chairs, okay, and everything was, you had a row and a column of chairs, and you wanted to figure out, I mean there might be hundreds of chairs. What's a real easy way to figure out how many chairs there are? Brooke, go ahead, you're going to say it. Count what?
The ones that are down.
Okay, count the ones that are down and count the ones that are across. So let's do this. Let's count how many are up and down. 1, 2, 3, 4. So there's 4 up and down. How much across? 1, 2, 3, 4, 5, 6, 7, 8. All right, so there's 8 across. So I don't have to sit there and count every single block, do I? I can just count how many across, how many down, and then do what? Dion? Multiply them together. And so you just go 8 times 4. And that would be what? 32. So there's 32 squares in here. Okay, again, pretend they're perfect squares. I know I didn't make it exactly right. I was just kind of just trying to get it to be right, but pretend they're perfect squares. So if this is like 8 inches and this is 4 inches, if I multiply together, 8 times 4 is 32, but what's inches times inches? What's right? What's anything times itself? You square it, right? So this would be 32 inches what? Squared. Or we say sometimes square inches. You probably heard that a lot, haven't you? 32 square inches. Like if your parents ever buy carpet for your house, they go out and they price the carpet per square foot. All right, so how many square feet, how many of these squares, they give a certain price for that, and you got to figure out what the area is in your room. That tells you how much it's going to cost. All right, so that's square inches. It's area. So we could have just called this one the length and this one the width, couldn't we? So how do you find the area of this whole thing? How many squares? When you find the area of something, what you're trying to figure out is how many perfect squares can fit inside that particular shape. All right, well, there's 32 squares in this shape, aren't there? So it's 32 square what? Inches. Make sense? So that's what you're doing when you find the area of something. But watch this. I'm not going to, in this chapter, I'm not going to call it length and width. I mean, there's nothing wrong with that. But I want to call it something that we're a little more familiar with. If I have a side And I said it was a rectangle, so that must be a right angle there, right? Because I did say it was a rectangle to begin with. So that's a right angle right there. Or this side right here is what to this side? Give me a better geometry word.
Wait, what's
This side right here, this up and down side, and this side that goes across. They're perpendicular to each other, okay? If that's a right angle, they're perpendicular to each other. We've talked about things before that were perpendicular. Like if I said, I'm pretty sure we have. I'm trying to think back to when we did this, and I can't really recall. But I think we've talked about this before. If you have one side and another side, and they're perpendicular to each other, we say that one side, I think we did this. Anyway, one side is the base and one side is the height. Did we do that before?
Yeah.
What did we do that for? I'm trying to remember what we did that for. Didn't we find like when did we use base and height? When did we use base and height before? Polygons. Yeah, that's right. When we found the angles of a polygon and all that kind of stuff, right? We said we've got a base and we have a height and that kind of stuff. All right. So we did talk about base and height, and we said the base and the height have to be perpendicular. So look at this. Instead of calling this length and width, what could I call it? Call it base. Oh, what did I just do right there? I could call it base, and I could call it what? Height. So instead of calling it area is length times width, let's say the area is what? The base times the height. Okay? Or you could just put the B and the H next to each other like that if you wanted to, couldn't you? All right? The little X is for times. Either way. You okay with that? Now, that's of a rectangle. Yes? Because it's more familiar with stuff we've learned before, and we're going to use this in another formula as well. Actually, not just one other formula, several different formulas. Okay? So I don't want to call a rectangle length and width and then call something else base and height. I want to keep everything consistent. All right? And let's just use base and height all the time. Now, again, what must be true? What must be true about the base and the height? They have to be what to each other? Perpendicular. Perpendicular. So the base and the height, you might want to jot that down in your notes, the base and the height must be perpendicular to each other. That's going to help us for what we're going to do next. Now this is a rectangle. A rectangle is just a special type of other four-sided figure we've talked about. We talked about quadrilaterals. We had a whole chapter that talked about what? There are four-sided figures. Quadrilateral is a four-sided figure, but what type of special quadrilateral did we have a whole entire chapter that we discussed? Well, that was part of that chapter, but in general. Starts with a P. No, it's more specific than a polygon. Could be 7, 8, 9, 10 sides. Okay, parallelogram. That's right. Okay, parallelogram. Do you remember parallelogram? I'll tell you what. Let's scooch up here and get me a parallelogram. There's one right there. And let's go back down to where we were. And let's put a nice parallelogram right there. Whoops. Here we go. Alright, so there's, come on, there we go. Alright, there's a parallelogram. Now, this is not a rectangle, is it? These are not perpendicular to each other. Alright, so what I got to figure out is if I want to find the area of this thing, I got to figure out a formula for the area. And I'll tell you the formula right now. The area of any parallelogram, not just a rectangle, but any parallelogram is the same as a rectangle. So what's the area of any parallelogram? It's the base times the height. That's good. Okay, but a little problem here though. On a rectangle, the base and the height were already perpendicular to each other. What if I call that the base? Am I going to call this slanted one right here the height? Why can't I call that the height? Because it's not perpendicular to the base. That's right. And that's a problem that a lot of students have. I hope you're paying attention. All right, let's make sure we don't make this mistake. A lot of students, even after I teach this, will call this the height. They'll think, oh, it just is the one that attaches to the base. No, it doesn't just attach to the base. It has to be what to the base? Perpendicular. This is not perpendicular. I do not call that the height. What do you want to use? Let's use blue. Watch where the height is. If I start at the top, I can start anywhere at the top. I'm going to start just at that corner right there. And if I drop this thing, now a lot of people say straight down, but we don't say straight down. What do we say? Perpendicular. Okay, if that is perpendicular to the base, what is that blue line right there called? That has to be the height. Okay? Does that make sense? That's very important that you understand that the height is perpendicular to the base. There it is. Look, I could have drawn the height anywhere from the top. As long as I draw it perpendicular to the base, that's the height as well, isn't it? I could have drawn the height right here if I wanted to. Because look, if this is a parallelogram, what do we remember about the two opposite sides of a parallelogram? Do you remember what the length of this side and the length of this side is on a parallelogram? Nobody remember? The opposite sides are what? Are equal to each other. That's right. So if this is the base, I could also consider that to be the base as well, couldn't I? Right? So if they give me that, just because it's not on the bottom, it's still the base. If I call this the base, then any of those blue ones have to be the height. Watch this. I could find the height another way too. Sometimes they do this. Sometimes they'll take this base and extend it out. All right. Do you remember seeing this? Yeah, you did this kind of stuff when you learned area of a triangle and stuff like that when you were a kid, right? Probably middle school is my guess. All right. So watch this. That right there could be the height as well. Even though that's not inside the polygon, inside the parallelogram, that could still be considered the height because it goes from the top perpendicular to the bottom, to the base. Even though we had to extend the base out a little bit, all right, that's still the height. So all of these could be considered the height. Notice they're all exactly the same length, aren't they? All right, so it doesn't matter which one we use. I just throw a whole bunch of them in there, all right, because sometimes they tell you this one here, this one here, this one in the middle. Sometimes they extend it and they tell you this one. I just don't want you to be confused about which one could be the height. Any of those could be the height. As long as it's what to the base? Perpendicular. Okay, as long as it's perpendicular to the base, then that is the height. And the formula is exactly the same as a rectangle, which is nice. It's just the base times the height. So if they tell you the base is 5 and the height is 2, what's the area of this parallelogram? It's just 10. It's easy. You just multiply the base and the height. Now sometimes, though, you're going to have to rely on some of the stuff that we learned before. You might have to rely on some trig. All right? So don't think that we completely forgot about that stuff. So when I said this chapter is a little easier than what we've done, it is in a way, but you're still going to have to remember some of that stuff that we've done before. All right, some of that trig stuff is going to have to come back to you depending on the problem. All right, let's keep going, and then we'll worry about some examples. Well, we won't. Hopefully, we won't worry about them, but we'll do a couple examples. Let's see. Let's make a triangle. I already got one up here. Let's just get an ordinary, regular-looking, acute triangle. All right, and actually, you know what? Before I do that, let's do this. Let's go back to this rectangle. Now, it's a rectangle, isn't it? So it's a right angle right there. What I'm going to do is I want to try to find what the area of a triangle is. Okay? Rayvon asked me before, why did we change it from length times width to base times height? This is one of the big reasons that we did this. Okay? Because of this. Oops. Ran out of room. Let me do this again. If I connect this to here, we call that a diagonal. That's not new. We've talked about diagonals before. Now look, if this was the base and this was the height, because it was a rectangle, if that was the base and the height, let's just talk about the about this thing right here. What is this thing? That's a triangle, isn't it? I'm just shading it in. Is that trying to shade it? Oops, I missed it a little bit. There we go. A little picky. Alright, so there we go. I'm looking at that triangle right there. Well, look at this triangle and look at this triangle. What do you think are true about both of those? Yeah, congruent's a better word. Okay, they're congruent to each other. Alright, if you didn't believe me, this would be considered the height as well. Let me make that white. Okay, that would be the height, and that would be the base. Now look, the bases are the same, aren't they? They're equal to each other. The heights are the same. They're equal to each other. I got an angle in between. So look, side what? Angle, side. You remember doing that? So this triangle is congruent to this one. Not just because I said, but because we proved it by side, angle, side. Remember all that? Good. So look at the triangle compared to the rectangle. The area of the rectangle, I'll put R for rectangle. The area of the rectangle is the base times the height. Would you agree? But that triangle is how much of the whole entire rectangle? It's half of it. That's right. So the area of the triangle, I'll put T for triangle, is a half times the base times the height. Or you could write it another way. You guys said it. Yep, base times height over 2. I don't really care which way you write it. Either way is perfectly acceptable to me. So there you go. That's how they came up with that 1/2. You ever wonder why they did that on a triangle? It's exactly why. Because the triangle is half of the rectangle. All right, so if I call this the base and the height, the triangle is 1/2 the base times the height. So that's our formula. That's our second formula. Basically, we have two formulas, don't we? We have the area of a parallelogram, which is base times the height, and now we have area of a triangle, which is half the base times the height, or base times height divided by 2, which is the exact same thing. Now that was nice and easy because this was a right triangle. We already knew they were perpendicular to each other, right? Because it was a rectangle to begin with. But we have actually 3 different types of triangles we're going to talk about. So let's do this. There's the first one. All right. Now, what if I called? Oops. What if I called here to here the base?
Then from the base up is the height.
From the base up to where? Up to here?
No, to the top.
To the top. That's right. To the very top. So let's do this in a different color. Let's go from the top. Now, a lot of people say straight down, but we say what? Perpendicular to the base. All right, so that blue one right there is your height. So that's a little bit different. That height is not really one of the sides of the triangle at all, is it? Okay, so you got to go from the top perpendicular to the base. So that would be your height. And that's easy. I don't think I have to put any numbers in here, do I? To find the area of that thing, yeah, you go base times height, and then you just divide it by 2 is all you do. Okay, yep, either way, it's fine. I don't care. I probably use this just as much as I use that. Okay, either way, it doesn't make any difference. So base times height divided by 2. We good with that? So sometimes the height is inside the triangle like this. Sometimes the height is part of the triangle. Sometimes the height is one of the sides of the triangle. For instance, it would have to be a right triangle. Exactly right. Good. So look at this. If this was a right triangle and this was the base, guess what? This would be the height. And that's actually one of the sides of the triangle, isn't it?
Yeah.
It's not inside the triangle. It's not outside the triangle. It's actually part of the triangle. That's probably the easiest area that you'll do if they give you a right triangle to find the area of that thing. All right? And again, how do you find the area of it? Just base times height. Multiply those two numbers together. Divide that by 2, and then you've got the area of the triangle. What are we doing to find the area? We're trying to find out how many of those perfect squares can fit inside that triangle. Does that make sense? That's what we're trying to do. Okay, we got another type of triangle. Before, this was an acute triangle, wasn't it? All right, because they're all acute angles, all angles less than 90 degrees, so the height's going to be inside the triangle. Well, actually, I shouldn't. It all depends on which one the base is, I think. Well, anyway, this height is part of the triangle itself. Let's look at another type of triangle. What type of triangle do you think we're going to do? Yeah, let's do an obtuse. Yeah, it can be outside. Now, it could also be inside. I don't want to confuse you, though. But let's do this. What if I gave this as the base? It's a weird-looking B. This one right here. Okay? That's the base right there. Let's stick with blue since we've been using the height in blue. So where's the height? Well, it's from the top perpendicular to the base. So what if I went to here? Would that be perpendicular? Now watch this. If I went to here, that would not be perpendicular. What if I keep going that way? It makes it even worse, right? I'm getting further away from 90 degrees. So what do I have to do? Yeah, bring this, and so it's going to be about right there. Do you see that? So that right there is going to be the height. How do I know it's perpendicular? Well, I take this and I extend it. Right? We extended earlier. Okay? So we extended the side right here. It's supposed to be a right angle. And now this is the height because it's perpendicular to the base. Even though it doesn't touch the actual side in the triangle, it touches the extension of that base. Okay, look. If this is the height and this is the base is still just part of that triangle, isn't it? The base just goes from here to here. For some reason, people, and I could kind of see maybe why, some people think, oh, if I extended this all the way out, now my base goes from here all the way to here. But it doesn't, okay? The base is just the length of the actual side of that triangle. Does that make sense? So don't include that extension part right here. The base is still from here to here, but now this is the height. So I would take this number times this number divided by 2, and I got my area. Yes?
That's what I was going to ask. Since the height's outside, it's still divided by 2.
Yeah, you still do the same exact formula as you always would. Okay? Still base times height. But notice the base. I'm not taking that length and adding it to this, am I? I'm just taking whatever that base is and calling that the height.
Okay.
Now look, I don't want to confuse you too much, but what if I called that the base? We'll make it a different color. What if I call that the base?
The height would still be the same.
Would it be the same?
No.
No, because that height is not that blue one's not perpendicular to this. I would have to go where? I'd have to go from here, wouldn't I? Now this time the height's actually inside the triangle, isn't it? Okay? So again, it depends where your base is. So if that's my base, this right here, we'll keep this color coordinated here. If I call this from here to here the base, everybody see that? Oops, it's supposed to be an arrow. It's a little sloppy. If I call that whole thing the base, then this one right here would be the height. So it all depends on which one you call the base, as if the height's inside or outside. What if I call, we'll make this look really crazy. What if I call this one the base from here to here? Then where would the height be?
You're taking it a little too far now.
Look, what if this one was the base?
The height would
Then I would have to extend it. No, it wouldn't be the same thing, because that's not perpendicular to this line right here.
Really far.
Yeah, it would have to extend out like this, wouldn't it? Like this, and then I would have to go like that. I told you it was a little bit trickier.
Like this, Mr. Hammer.
Look, but look, this is the height now. If this was the base, if from here to here was the base, let's even make that color so you can, everything's color coordinated here. All right, look, if this is the base, then this right here is the height. How do you know it's the height? Because I extended it out, I took it from the opposite side of the base, right? And I made it perpendicular to where the base would be if I extended it out. I think I have to show you that stuff because they're not always going to have the part that it's sitting on be the base. It'd be nice if it always did, but it's not always going to do that. All right? All right. So that's the most confusing one if you have obtuse. All right, let's see what else we have.
What other things do you have in your bag of tricks?
I think that's it.
Yes.
Let's do this, though. Let's do an example. Let's do an example. I probably could, sure.
Just like you did on the test, you did the square root. Yeah.
Now, if I just told you the base and the height, it wouldn't be much of a challenge, would it, to find the area? If you knew exactly what the base and the height were. So sometimes they're going to make you think a little bit. This one, they don't even ask for the area. They actually tell you the area. The area is 357 square inches. But they do tell you this. They tell you this length right there is 34. And I'll do this in a different color for you. Let's go blue since we've done height in blue a lot. Actually, I don't know that's a right angle. I need to erase that. Looks like it is, and I just... Well, you gotta think a little bit. Let's watch. They tell you that is X, and that's what you're trying to find. Now, let's pay attention. I hope you're watching. Look at this. They tell you the area, don't they? Okay, and they ask for the what? What is this X? It's the height. How do you know it's the height? Because it's perpendicular to this side right here. So this would be your base, wouldn't it? And this right here, I'll tell you what. Let's not even call it X, even though they do in the problem. Let's call it H for height. Is that all right with you? So they tell you the area this time. They don't ask for the area. They tell you the area, and you got to find one of the sides. So let's write down our formula. I think that's always the best thing to do. Area is, you could go 1/2, or you could go base times height divided by 2, whatever is more comfortable for you. So we're going to plug some stuff in now. What do we know? We know the area. So what are we going to plug in for that? 357 equals the base. Do we know the base?
Yes, sir.
What is it? What it is. All right. Write that one down. All right. 34 times what?
X.
Yeah, we'll call it H for height. And then do what? Divided by 2. And now, this is a little different. It's not just a matter of multiplying two numbers together, is it? We got to do a little bit of algebra, which is not that big of a deal. 357 equals, now look at this, 34 divided by 2. That actually comes out nice and even. So do you know what 34 divided by 2 is? It's 17. It's 17 times h. How do you get h by itself? Divide by 17. Okay, we've done this a ton of times. You could have, if you wanted to, that's a good choice. Watch. You could have multiplied both sides by 2 and then divided by 34. Everybody see that? That would have been fine. You could have done that. Okay? I just decided since 2 went into 34 evenly, I figured it was just as easy to do it that way. But you're right. You could have multiplied by 2 and then divided by 34. All right? Because sometimes if that didn't come out nice and even, sometimes you probably want to do it that way. All right? So now you just figure out what that is. I just happen to have a calculator here. Nice and handy. It just happened to. So it's 357 divided by 17. And that comes out to 21. How about that? 21. And that's how tall the height is. It's 21. If that's inches squared, it's 21 what? Inches. Well, the height's not squared. Okay? The height's just in inches. So that would be 34 inches, and that would be 21 inches. Yes?
I'm confused where you got that from.
Where I got what from? The 21? I did that in my calculator. I went 357 divided by 17, which is 21.
Oh, so you just divide 34 by 2 and then just leave the h? And then
That's what I did. I went 34 divided by 2, which was 17. Okay, I'll leave the h, right? So it's 17h. How do I get rid of 17 if it's being multiplied? I divide. So I divide both sides by 17. I get 357 divided by 17, and it's 21.
Okay.
What if it was this? I'm just completely making this number up. What if it was 34h? Well, it wouldn't be actually divided. I tell you what, let's change this number. We'll keep the 2. Let's say this was 37, okay, divided by 2. Now, 2 doesn't go into 37 even, does it? So here's some algebra. This is just algebra for you. I'll get rid of the 2 first. How do I get rid of the 2 if it's being multiplied?
Divide.
I'm sorry, I lied. If it's being divided, I was getting ahead of myself. If it's being divided, how do you do it? You multiply. Sorry about that. I was getting ahead of myself. Right, you multiply by 2. Then how do you get rid of this 37 if it's being multiplied? You divide by 37. Plug that in your calculator and that's what you would get. Everybody see that? The only reason that I divided here just because it came out even. I probably should have showed it to you like that. Yes?
So even on a equilateral triangle, it's on the whole page, you have to put half.
You still got to put half. Doesn't matter what kind of triangle it is. Doesn't matter if it's equiangular, right, obtuse, acute. Doesn't make any difference. Because isosceles, it's 1/2 the base times the height. Doesn't matter what type of triangle it is. Okay? Everybody with me on that?
Yeah.
Okay. Let me give you a worksheet, and then you can do this tonight. Have fun with that.